Welcome to our screencast of Diana. We start in default mode by posing the question, who played in Casablanca and was married to a writer born in Rome? And we click submit. So this is the result that we get. So for the question, we obtain the following structured query. So we're talking about M of type person, M acted in Casablanca, M is married to N, so this is the main join in the question, and then N is a writer, and this is another join, so N was born in Rome. We can take a look at the intermediate output of the mapping process. So here we have concept mentions or concept phrases, relation mentions, the mappings of those. So for concepts we have, for instance, for Casablanca, this is the Moroccan city Casablanca, this is the film called Casablanca, and here for example we have Casablanca can refer to the White House. Similarly, Rome can refer to the Italian city Rome or one of multiple Romes in the US, and so on. We also have something similar for relations. So we have played in. It can map to died in, strangely enough, with some very low weight. But it can also map to acted in, as it does in our case, or played in the sense, so it has musical role in the sense that somebody plays an instrument. And similar for other relation mentions. We can also take a look at natural language triple seeds. So one triple seed is who married writer, and this forms the core of a semantic triple later on. Another one is who played and Casablanca. Those are generated using dependency graphs or dependency parses. So this is one possible dependency parse, and here for example we can see that played is connected to Casablanca through a preposition as one argument, and then another argument is who. Married has also who as one argument, and then the other one is the writer, and so on. If we hide the intermediate output for a minute and click on download graph, so this would show us the dense subgraph of the disambiguation graph. So if we click here, this is what we obtain. So this graph has a lot of semantic nodes or S nodes that are disconnected because of this disambiguation process. But at the bottom here we can find the dense subgraph. So if we take a look on the left side, we can find the Q nodes or Q units. In the center we can find the P nodes, so those are the phrases or dimensions. And on the right hand side we can find the semantic items. It's also easy to see how the Q units have some P nodes in common, and those generally correspond to joins later on. Going back to our interface, we can take a look also at one of our sample queries. So if we click on show sample questions, and let's click on the second one. So who played in a movie directed by Spielberg? So we click it, and this is what we get. So for the question, we obtain the structured query, Z acted in A, where Z is a person, A is a movie, and Steven Spielberg directed A. So Steven Spielberg directed the movie. Again, we have a person acting in a movie that's directed by Steven Spielberg. As we did before, we can take a look at the intermediate output. So we have the concepts, or the mentions of concepts, the mentions of relations, their mappings. So Spielberg can either be Steven Spielberg, or it can be Sasha Spielberg. Similarly for relations, we have the triple seeds, the natural language triple seeds. We have semantic coherence. So for every pair of semantic items, where semantic items are either semantic classes, entities, or relations, we have some coherence value, which would tell us how compatible this pair is. We can also take a look at the parse trees. So we have two of them here, and each one would generate its own dependency graph. One other thing to look at is the projection of the question. So what is the target of the question? And here, in this case, the target is the who. So the main information we would like to get from the question is expressed by who. If we hide the intermediate output now, and we can click on download graph to see the dense subgraph of this disambiguation. So if we click, this is what we get. Again, we have a lot of disconnected S nodes because of this ambiguation process. But here we have a dense subgraph with the Q nodes, the P nodes, and here we have the semantic nodes. We can also take a look at the joins. So here the join is happening around a movie. Going back, let's take a look at the advanced options. So let's disable the mapping process and the generation of a structured query so that we can take a look at our dense subgraph. We will keep some pre-processing just to make this disambiguation graph a bit nicer to look at. And we can click submit. And this is what we get. So we didn't allow the process to go until the end. So the mapping process, this is why we don't have a structured query where we had it before. But we can of course take a look at the disambiguation graph before it was processed to generate a structured query. So if you click on download graph, this is what we get. So we can see the disambiguation graph with its Q nodes, the S nodes here, the P nodes, and here we have the S nodes. One other thing that we can see are the mutual exclusion nodes. So we have played can be either a phrase mapping to an entity called played or to one of multiple relations. But in the final interpretation, only one of those can appear, hence the mutual exclusion condition or constraint. So this is our presentation of Diana. Thank you very much.